Hello, everyone. I want to thank you for joining me today for this webinar on combustion analyzer maintenance and troubleshooting. I appreciate your time. I know that basically everybody listening to this is on webinar overload, and I can appreciate it. We've attended a lot of webinars ourselves for our industry, and it's definitely understandable. So I appreciate your time today. My name is Tyler Nelson. I am the Instrumentation Sales Manager for the Americas here at the Sauerman Group. I proudly hold my Master HVACR license. I'm a NATE instructor, and I come from over 25 years of experience in the industry between the contracting side and the manufacturer side of the business. My contact information is listed here. I'll also have it again at the end of this presentation, but it is listed here. If you take a look on your screen here, you're going to see a questions section. So if anybody has any questions, please feel free to ask any questions in that questions section there. And if you need to reset or do anything with your Wi-Fi, should be a refresh button there for you to take care of that as well. Who are your friends here at the Sauerman Group? Well, we come from over 40 years of experience in the manufacturing and design of instrumentation. We provide HVAC combustion analyzers, various HVAC testing instruments, refrigeration manifolds, industrial emissions gas analyzers, and also IAQ monitors. And we also provide training and service on those as well. We're an innovative global company with a NIST traceable lab, and we are available in over 65 countries. Some of the things we're going to go over today are combustion analysis in the modern contracting world. We want to go over why perform a combustion test and why do you even need to use an analyzer. We're going to go over the importance of measuring. We're going to touch upon commissioning a new piece of equipment. A lot of you don't think that you need to use a combustion analyzer on a new piece of equipment, and you do. We're going to go over the importance of performing seasonal maintenance using your analyzer. We're going to go over some combustion troubleshooting, draft. We're going to touch upon cross-contamination and how to check for it. We're going to go over a check for a cracked heat exchanger that you can utilize with your combustion analyzer, how to properly maintain your analyzer, and the importance of sending your analyzer in for maintenance and calibration. The combustion fairy. Now, I know you've all heard of the tooth fairy, and I know there's some debate out there as to whether a sock fairy actually exists. I know when we put our socks in the laundry and we come back with less socks out of the laundry, something's going on there, and I understand it. However, let's talk about the combustion fairy here for a second. This fine gentleman doesn't exist, although it would be a little bit creepy if he did. So since he's not testing for you, it's very important that you perform the combustion analysis on the equipment that you're working on. And gone are the days when we were contractors of just walking in and kind of looking at something and saying, oh, looks pretty good. Check the pressures on the boiler, check the filter. That should be good. Let's just have the customer sign the ticket and move on to the next. That's done. It's kind of like when you go to the doctor. You know, the doctor is going to run an extensive amount of diagnostics on you, blood pressure, urine, all these different things, height and weight. When you're in there for your physical, you essentially want to do the same thing on a piece of equipment. So you need to look at it. You need to see if there's going on, if anything is going on underneath the surface that's a precursor to some potential issues down the line. Don't just judge a book by its cover. Look deeper. So when we talk about the changes in our industry and combustion analysis in the modern contracting world, it comes down to three basic areas or criteria. The first is what you see here, this manufacturer's example. The manufacturers want you to test. It's in all the manuals. So that manual that you currently might use as a knee pad, it's in there, important combustion information. They're also starting to require it for any extended warranty for a customer that you submit your combustion analysis to them. So it's becoming important from the manufacturer side. It's important from the liability side, which is number two. Liability is huge. You know, one of the things we produce a lot of in this country are attorneys. Very difficult to find a good service tech, but we sure have a lot of attorneys out there. And they're looking to litigate at every turn. So it's important for you to protect yourself. Don't trust anything and make sure that you test to protect your own liability. And the last is that, and number three, is that it's what's best served for the customer. The customer deserves our very best. And to be able to combustion test on a fuel-fired piece of equipment that they have is putting our best foot forward and is the most professional approach and will also set you apart from the competition. Another little piece here for the manufacturers, they're even creating these test ports for you so you can actually see that they want you to test, where I'm highlighting here. See these test ports here? They're trying to make it as easy for you as possible. And they are essentially passing the liability on to you. They've manufactured and designed a piece of equipment that they feel will run at optimal levels, providing that you set it up correctly and install it correctly. And that's where combustion analysis comes in as well. Why should we combustion test? Well, first and foremost, it comes down to safety, and that being CO safety. Everything else follows suit after that. So once we have the safety factor established and we're making sure that not only our own personal health is assured, but the health and well-being of those living or occupying the space is assured, then we need to look at the diagnostics. We need to measure for efficiency of the piece of equipment. We want to make sure that we're complying with the emissions regulations, make sure there's proper safety of the piece of equipment prior, during, and while servicing. We want to check the fuel pressure, check for cracked heat exchangers and the like. And also, again, it all ties back to limiting your liability. Those are the foundational reasons why we should test. Now, when it comes to why do we need to measure, there's 4 factors here. The first being that the boiler and furnace or boiler and furnace manufacturers want you to test. It's a requirement, as I just went over when I showed you a slide of the manual. They want you to test. Again, they've passed the liability onto your hands. It's up to you to set that piece of equipment up correctly. Not only that, it's up to you to test it when you're out there for any kind of service or maintenance visit. Second is compliance with federal, state, and local regulations. We want to make sure that we're adhering to the regulations for CO, for the efficiency of that appliance, and also for NOx. And as far as HVAC's professionals are concerned, it's our best foot forward. It is the best thing that we can do for our customer. It gives a complete service profile of the piece of equipment and provides confidence to the customer that they are actually utilizing their appliance correctly and that it's running safely the way that it was designed. And also, you can use your combustion analyzer as a sales tool. It can actually make you money through different diagnostic checks that you can do and for checking for cracked heat exchangers and some other things that I'll get into. And the last, which is number 4 here, is energy auditing and weatherization. It's a required tool for BPI contractors and the like. In order for you to get paid or for you to get final payment, you have to prove that the work that you did adheres to BPI or the different weatherization group specifications that are laid out for you. Commissioning a new piece of equipment. The question is always asked, but if it's new, why do I have to test it? Didn't they set it up perfectly for me before it left the factory? For all intents and purposes, they try to, but you never want to assume that that is the case, because remember, the liability is on you. You never want to assume. There are no absolutes in life. So you need to test that new piece of equipment to make sure that the oxygen, CO, and all the other parameters are set correctly. Things can change in transit. When things are shipped, things can get jostled. Things can get shifted around. An internal piece of a component can actually drop and not be seated where it's supposed to be seated, which could cause an issue with your combustion. So it's very, very important to test for that reason. New equipment is also set up at sea level. You know, where do you live? What is what are the conditions where you're at? Are you at atmosphere? Are you at what elevation are you at? So you need to account for that. Are you living in Denver? Are you installing in Denver and this machine or this device was set up at sea level? So what are the conditions where you're at? You need to understand those and set the piece of equipment up accordingly. What is the gas pressure where you're installing? It can vary from day to day around this country when things are set up. So what is the gas pressure? And I'm going to get into the high relevance of that in a couple of slides and kind of drive that point home for you. It's in the installation manual, like I just discussed. The manufacturers want you to do it and need you to do it. Cross-contamination check for condensing systems. If you're installing a brand new condensing piece of equipment, do you have cross-contamination? And are you even aware that that is something that you can check using a combustion analyzer? Seasonal maintenance. You touch it, you're liable for it. Anytime any piece of equipment is touched, that technician who touches it is liable for it. You're responsible for everything that you touch. Not only can homeowners or building owners sue your company, but they can also sue you and your family. Again, you touch it, you own it. And I have here Massachusetts and New York court cases, just to name a few. Well, first one, Massachusetts. Some of you might be aware that about 3 or 4 years ago now, 37 houses caught fire and burned down in the state of Massachusetts. Well, that was an interesting case, and that was caused by an issue with gas pressure. I know the person who did the forensics on that case for the plaintiff and for the defendant, and found out that normally when gas pressure is delivered, we all know it's delivered in inches of water column. Well, in this case, in this Massachusetts case, the gas pressure was delivered to each one of those houses at over 300 psi. Yes, every time I say that in a live class, I see eyeballs the size of dinner plates when I say that, but over 300 psi. Luckily, it wasn't a high demand day and it was just domestic hot water that was being used that day. Otherwise, all 12,000 houses on that grid would have probably gone up in flames. So very important to test the gas pressure because it was a gas pressure issue. Never assume it's correct. The New York court case. I was in New York last year and I was talking about some issues with CO, and this gentleman brought up the fact that he was sued back in 1989 and wound up selling out of court for over $100,000. He was sued for unlawful death because he went to a rental property to check on whether or not the heat was working and to light the pilot light on a water heater that had gone out. Well, he made sure the heat was working fine, relit the pilot light in the water heater, and took off. About 3 weeks later, he received a summons that he was being sued for wrongful death that he wound up settling for because somebody had died from carbon monoxide because he was there and it did not do a combustion test. He was not aware that there was an issue. You can't tell how it's running just by looking at it. Again, don't judge a book by its cover. Don't just assume that, hey, you know what? We've installed a bunch of these things here. We've been the ones that have been servicing the same piece of equipment for 5 years. It looks good. Everything's fine. Don't make that assumption. Again, it's like going to the doctor. You could have something going on inside of you, even if you look like $1 million. Same thing with a furnace or boiler. There could be something going on inside of it, even though it looks to the eye that everything is functioning properly and sounds like it's functioning properly. Did the last technician leave it running correctly? You don't know. You can't trust it. And in today's world, you need to control the variables. It's very, very important that you test it because you don't know the last company that was there, if it was a different company, and you don't know which one of your technicians and how they left it and what kind of day they were having. And so it's important that you test it at each visit. Did the gas pressure change from the last visit? As I mentioned earlier, gas pressure can sometimes fluctuate day to day. So it's very, very important to verify what the gas pressure is and to make sure that we have our everything set up correctly with our gas valve and everything. Is the draft correct? Is it one of those situations where you go to open a furnace room door, you go to open it and it feels like it's fighting you and it's pulling back in the opposite direction like an airlock? That would be your trigger that something might be going on. You want to investigate that because that shouldn't be happening, especially if it's never happened there before and you've been there before. Did the homeowner decide to put walls up and a solid core door in that furnace room, restricting the amount of makeup air if it's an atmospheric system? Or is something blocking a vent with the way the high efficiency or condensing system is being vented? Or is there something blocking it from outside? So all these things you need to pay attention to, the draft and the like. Seasonal combustion analysis checklist. These are some of the things that you should be going over at every tune-up. Okay, want to verify the draft. Whether it's condensing or atmospheric, it doesn't matter. You want to make sure that your inches of water column is in that proper level or proper criteria. For those of you that don't know, for an atmospheric, it's minus 0.02 to minus 0.04 inches of water column. And for condensing, it's positive 0.02 to positive 0.08. Again, want to verify gas pressure at every seasonal checkup. Don't just assume the gas pressure is fine. You want to verify that. Combustion analysis. You want to perform your general combustion analysis. You want to look at what your oxygen is, what your CO is. If you need to measure NOx, you want to look at what your NOx is. You want to look at all these different criteria at your service visit or at your seasonal visit. You want to do a cracked heat exchanger test if you're noticing that you have very low oxygen or very high CO readings or other indicators on your analyzer that are showing that some numbers are askew or out of line, you want to perform a correct heat exchanger test, which I'll get into. You want to check for cross-contamination with the condensing system. Make sure that, since your furnace or boiler was installed there, or since you've serviced it last, that a neighbor that's in close proximity didn't decide to vent their appliance right by your fresh air intake, which means you would be sucking in the fresh air intake of the property that you're dealing with, you'd be sucking in their byproducts of combustion, thus creating a potential issue with carbon monoxide and also possibly producing NOx in that system. So that's something that you want to verify as well. Also, too, we have the ambient CO monitoring function of an analyzer that we want to be cognizant of. We want to make sure that the conditions we're working in are safe. A lot of you don't know that there is an ambient CO monitoring function on your analyzer. You have one. And that's one of the many tools that an analyzer can provide. So you want to make sure that the general space that you're working in is safe and make sure that you have situational awareness with it. Using your analyzer as a diagnostic tool. Essentially, we have three different phases here. We have diagnose, we have solve, and we have prevent. When we talk about diagnose, what direction is the combustion analysis pointing you in? Is there an issue with the draft? Is there a cracked heat exchanger? Do you have erratic oxygen readings? Do you have erratic CO readings? Is your CO spiked? What are the readings? The analyzer is going to assist you in providing you direction, as long as you're using it correctly and know how to interpret the data and know what components to go after reading that data. Next phase here is solve. You want to replace the different parts or catalysts. And after you do so, you want to perform another combustion analysis, a brand new one, to make sure that the changes or the fixes that you made solve that problem before you move on to your next job. So that comes into the heading of solve. The last one is prevent. You want to test at every visit to prevent issues and costly repairs. I have in here in bold. You want to be the pro and proactive. You want to take a proactive approach to preventing issues. That's why you should be testing at every visit. You don't want something sneaking up behind you to get you. You want to test at every visit and to be able to prevent future problems from happening if you notice symptoms when you're testing. Combustion troubleshooting as it relates to CO safety. Some of the things we want to look at, again, we talked about it earlier, the monitor the ambient CO, you have that function on the analyzer. But you also need to know what are the acceptable levels that the manufacturer has stated in the manual for what your CO should be. What should it be at steady state? What should it be at low fire? What should it be at high fire? You want to know what those are and be able to adhere to those. You want to check the source of the CO. A lot of times we assume that the source of the CO is the piece of equipment that we're working on, and then we go right after trying to find it. It might not be. You might have another fuel-fired appliance in that structure that is producing CO. You could have a vehicle parked that's running near a garage where a garage door is a little bit open and that's producing CO inside the space. So you want to verify the source of the CO before you proceed further once you detect it. You want to make sure that you're using your analyzer correctly. By that, I mean starting it up outside in fresh air and zeroing it out before you go inside and you test. And I'll touch upon that in a little while. You also want to know what your levels are. You want to know that it's 9 ppm max exposure over a 24-hour period by regulation. You also need to know that it's 35 ppm max exposure over an 8-hour period. So you want to know what your levels are. A lot of people assume they're much higher than that. It's not. It's 9 over 24 hours. It's 35 over 8 hours. And again, as we talked about it before, a lot of this ties into liability. What is a liability? What can happen to you? You can lose your own life. You can become, drastically sick, or the lives of the people that are in the space that you're working in can become sick or can die. So the liability is huge. You want to protect yourself by operating your analyzer correctly and making sure that you're maintaining proper CO safety. When we talk about combustion analysis, one of the things that comes up a lot is troubleshooting. And how do you actually use these things to troubleshoot? And here's a couple of slides I'm going to show you just to give you a taste what we cover in our trainings, because we have a much longer version of this class, or not much longer, but a longer version of this class that I do that goes into some more troubleshooting and some more tangible things to take away. But here's a few. First off is low oxygen or high carbon monoxide readings. Well, one of the causes of that could be insufficient combustion air. For oil systems, you probably or could possibly need to adjust your air band. Or for a gas system, check for proper combustion air. Do you have enough air for combustion? The analyzer will tell you such. Burner overfiring. Do we have to adjust the fuel? Do we have to check that? We have to make sure we have a proper fuel adjustment with the system. Do we need to back down the gas pressure? Do we need to increase the gas pressure? And then also we have low stack draft. Do we have to adjust or install a barometric damper? Do we have an issue with our induced draft motor not allowing the flue gases to terminate properly and leave the system properly? Or do we have a cracked heat exchanger? Those are some of the things that we need to check for. Another one for combustion troubleshooting is unstable oxygen or unstable carbon monoxide readings. A couple of things to highlight with this. Changing weather or atmospheric conditions. Again, like I talked about before, when you're opening a furnace room door, is it fighting you? Or even when you're opening a door to a residence, is it fighting you? Or to a room, is it fighting you? Those are indications that you have a different kind of atmospheric climate in there that needs to be investigated. So we need to check for that. Possibly install a barometric damper and the like. Cracked heat exchanger could be one of the causes of that. Again, you can verify that with your combustion analyzer, which I'll get to. Do we have an issue with excess draft? Again, adjusting with your barometric damper or installing a barometric damper. So these are just a few of the things that you can look at when you're troubleshooting a piece of equipment using your analyzer. When we talk about combustion analysis, draft is one of the foundational things that we need to check. And I've touched upon it a little bit here earlier, but draft is a pressure measurement, and it lets us know how efficiently and effectively and at the rate the byproducts of combustion are leaving the combustion zone. When we talk about draft, we have two different types of systems. One is an atmospheric, the other one is a condensing. And they both operate under different sets of criteria and are very unique. With an atmospheric system, you're using makeup air or room air for the combustion and draft process. And with a condensing system, you're using fresh outdoor air through a fresh air intake for your combustion and part of your draft process. When we talk about atmospheric, some of the challenges to an atmospheric draft system or an atmospheric system is not enough makeup air. Again, do we have a furnace room that's been changed that's impacting the amount of makeup air in that space? Do we have incorrect stack size? Do we have a barometric damper that's being hung up? So these are some of the things to check when we look at atmospheric. When we talk about condensing, do we have byproducts of another combustion process coming down our fresh air intake? And I'm going to talk about cross-contamination here in a second. Do we have our exhaust stack too close to our fresh air intake, which is creating a problem? Or do we have an issue with an induced draft motor on a condensing system? In other words, are we not able to expel the combustion gases and the byproducts of combustion properly out the stack or out the exhaust because our induced draft motor is not functioning properly? When we talk about cross-contamination, a lot of technicians are not aware that combustion analyzer can actually solve that issue for you. The way that you do that is very simple, and that is by measuring the quality of the fresh air intake that you have, because that fresh air should be 20.9%. If it's not, and it's anything lower than that, you have cross-contamination. And that's one of the other things that we cover, again, more extensively in our training programs, but that's just something to keep in mind. And it's a feature that a lot of people don't know an analyzer can perform for you. Combustion troubleshooting, one more thing here. We have our cracked heat exchanger test. I know those of you that have been in this business for a while are used to using visual inspection for the most part and trying to find where a crack is. But a combustion analyzer is a very useful tool when finding a crack in a heat exchanger. It essentially involves you, putting your probe in the stack, firing the system on, letting it run, and then looking at your oxygen. And again, we go farther in depth than just that brief explanation in our training. But in a nutshell, your combustion analyzer, through the oxygen readings and through the excess air readings, can let you know whether or not in a forced air system, whether or not you have a crack in that heat exchanger. And what it does, it's a game changer because it levels the playing field. Because a very inexperienced tech can test for it, and an experienced tech can test for it. And it's a feature that an analyzer provides that can actually make you money as a service tech. So it's very important for everybody to understand that that is one of the important features. Analyzer maintenance. Let's take a look at this for a few seconds here. First off, startup and shutdown protocol. In a nutshell, turn your analyzer on outside in fresh air with no probes or hoses attached. When you shut it down, turn it off with the probes and hoses attached to allow it to purge the previous byproducts of combustion that might be in there from a previous test out of the analyzer. So again, start it up outside in fresh air, turn it off with the probes and hoses attached. Once you turn it off, then you could take the probe and hoses off. But when you turn it on, make sure they're not attached, and again, outside in fresh air. You want to establish a proper baseline for yourself. You want to check for air leaks. Check for air leaks around the pneumatic panel. Make sure there's nothing leaking out. Make sure that everything is fitting snug underneath here. Make sure your probes and hoses don't have any air leaks. Make sure no one has stepped on your hoses with their work boots with a nail in them by chance, which has happened before. So make sure that you're taking care of your hose for your combustion analyzer. Cold truck storage. Make sure that we are bringing our analyzers in at night during the winter months. I don't care where you are, as long as it gets below freezing, you want to try to bring that analyzer in at night, because it's like your cell phone. You're not going to leave your cell phone in a freezing cold truck and then stick it into a 300-degree oven the next morning and expect it to function properly. It's the same thing with an analyzer. An analyzer is a handheld computer. It's an electronic piece of equipment. It doesn't like heavy temperature fluctuations. It can shorten sensor life and shorten the life of the analyzer. Want to make sure we're maintaining our water trap. Make sure we're dumping any kind of condensation in our water trap out of our water trap, and make sure that we're maintaining that properly. Want to make sure that we're watching our O-rings. So make sure when you're dumping your water trap that you're not losing your O-rings when you're doing that. Filter maintenance. If it looks discolored, change it. If it looks nice and white and clean, chances are you're good. Just check the integrity of it. Make sure it hadn't been saturated and it's actually degrading at all. So again, go by color and check the integrity of it. As I talked about before, protect your hoses. Make sure that you're not stepping on them. Make sure there's no holes in them. Make sure that you're putting them back in your analyzer case when you're done so that they don't get jostled around and then don't get compromised. You want to make sure that you're smoke testing before working on an oil system. Don't just go and use your combustion analyzer on an oil system if you haven't done a proper smoke test, because what you're going to do is, if it's a dirty system, you're going to pull all that soot and debris into the analyzer. And analyzers hate that, so don't do that. Yearly maintenance and calibration. This is very important. Tomorrow at 2 o'clock, one of my colleagues, our industrial sales manager, Mr. Kerry Holman, is going to be putting on a webinar on the importance of calibration and seasonal maintenance. And he is going to touch upon, again, calibration, and he's really going to drive the point home. So if any of you have not signed up for that, I encourage you to sign up for that. It's a very good webinar, and Kerry is excellent at what he does. A couple videos we have here. Here's our YouTube address, Sauerman-Americas. So check out, we have different videos for you. If anybody gets jammed about in the field and needs help with something, not only can you call our office so we can give you help, but there's also YouTube videos in there to give you some direction. Then we have our different products here. Just to touch upon these, we have you covered no matter what end of the spectrum you're on. If you're doing strictly residential, we have your E500, which is meant for the contractor who doesn't do a lot of combustion analysis on a daily basis, or one that does strictly residential. This has you covered. This is our entry level or value engineered entry into the market, but also very effective. We have our CA120, which is one of our newer models with our newer chassis design. It has a very robust 8,000 ppm CO sensor with NOx filter. And speaking of that, all of our combustion analyzers have a NOx filter on their CO sensor. And for those of you that don't know what that is, that prevents any crosstalk. And what that means is that you're not getting an inflated CO reading when you're doing your analysis. You're getting a proper and accurate CO reading. So this is our non-printer version of this analyzer here. Again, slightly different chassis design, but this E1500 here, this is our flagship model. This has an industry exclusive built-in internal thermal printer, very effective piece of equipment. As you can see, these have color displays. And this is our 4500 series. This is meant for the contractor who is dealing with both residential and commercial. We also have our gas sniffer here, which is very important as well. Our 7899 can detect LEL, low explosive limit, so a very effective gas sniffing tool. So we have our residential and commercial, and one that covers all ends of the spectrum, residential, commercial, and industrial. And just a little special that we have here, it's our trade in and trade up. Now, a lot of you are performing your seasonal maintenances or about to begin to perform them on your various furnace and boilers that your customers have. You're going to encounter pieces of equipment that have seen better days and that you're going to recommend replacement. I encourage you to look at your analyzer in the same way. If you've had it for a while, if you're on a competitor's model and that model is giving you headaches and you're like, I'm just going to tune into this webinar today, see if I can learn anything new. Hopefully you have up to this point. But something you should know is that we offer very, very good trade-in program. So my email address is here on the bottom of this piece, but I'll also have it on the next slide as well, or in 2 slides. I'll show it to you again. Reach out to me. Let me know what kind of analyzer you have, and let me know what your use pattern is or what you're using it for, and I will come up with a cross-section of different products here that will meet your needs. And then we can talk about trade-in numbers and everything else. But we offer a very aggressive trade-in program. So it's time to get rid of the old lagging piece of equipment, the old analyzer you're using, and to give yourself something that's dependable. We have so much volatility in today's world with COVID-19 and everything else going on. Why don't you give yourself something that is dependable, that's been established, and that you can rely on? Get yourself a new analyzer. So again, contact me for any kind of trade-ins that you're interested in doing. I will entertain them and see what we can do for you. Last, if anybody here has any questions, we have our questions tab here. Feel free to ask them. I see we have a poll here that we have going. I'm just going to dip down in here for a second. See what we've got here. And we got a bunch of things here. All right. Okay. Got a little surveys here. I want to see if anybody has any questions. If nobody does, which I'm sure you're all experts on, just kidding. Again, I appreciate everybody's time today. I know your time is precious, our time is precious, and everybody's on webinar overload. So where do I send my analyzer in for service? You can actually, we have an RMA system. Very good question, Bill. We have an RMA system here that makes it easy for you. You can email me, or you can also go on to our web address, which one of my colleagues will post, I'm sure. If not, you can just email me. I'll need your model number. I'll need your serial number and your full contact information. And we will issue a return authorization number for you. And that is our tracking number. And then once we have that in-house, we will then go about taking care of your service for you. We provide calibration service. We have all the sensors that you're going to need. We run full diagnostic checks on your piece of equipment so that when you get your piece of equipment back in your hands, you can rely on it. And we all know that this time of year, you need to rely on your piece of equipment like never before. So it's time to remove the volatility from your life and get yourself set up with something that you can depend on, whether it's service from us or whether it's a new analyzer from us. We offer some of the fastest turnarounds for service in the industry. The average service turnaround in our industry, just so you folks are aware, in case you're not, is anywhere from a minimum of 4 upwards to 8 to 10 weeks. We are running anywhere from 7 to 15 business days on average. So we are the fastest in the industry, and we take great pride in that. Once again, here's my contact information. Just to recap, my name is Tyler Nelson. It was a pleasure to meet with all of you today and to have you attend. If you have any questions, please feel free to call me on my cell. You can email me. I'm happy to assist you. And if anybody is interested, we do conduct live trainings around the country. So depending on where we're at, depending where we're going to be or I'm going to be. I would be happy to meet you in person and actually shake your hand once we get past these interesting times that we're in. We get a few more questions here. Let me just take a look here. Let's see here. We have somebody replying on our behalf here. Hold on one second. How often should you calibrate? Very good question. Okay. I'm going to give you the perfect world question, and I'm going to kind of just elaborate on it a bit. Perfect world, whether it's a 1500 analyzer that you reference here or 4500, doesn't matter. Perfect world, an analyzer should be calibrated every year. And because it's like you're doing your maintenance on your customer's furnace or boiler every year. It's the same thing. You want to make sure that the analyzer is running properly. Also, you want to have a valid calibration certificate, which is something that we issue with where every time we calibrate a piece of equipment. That's your legal and binding document that shows that your device has been calibrated and checked. So if you're ever called into court, they can't throw your combustion analysis results out of court because you have a valid certificate. If you have a valid certificate, those results that you're producing are valid. Also, too, when we talk about calibration, a lot of things people kind of lock into their heads is sensor life. Well, when we talk about sensors, perfect world scenario is oxygen sensors will last you 2 years because they're exposed to oxygen 24/7, 365. When we talk about the actual other sensors, they can last, whether it's CO or anything else, they can last anywhere from 3 to 4 years. So, but when we talk about the calibration and how often you should calibrate in sensors, again, my colleague Kerry is going to be doing this presentation tomorrow, and he is excellent. I strongly encourage you to check it out. It's not just, you're going to come out of it with a lot of information. It's not going to be things that you already know. He's going to open your eyes to a lot of things that you didn't know. And as a result of it, you're going to be a much smarter service technician or a much smarter distributor if you're listening to this as one of our distributors. So I think that covered everything here. Again, I would like to thank everybody for attending today. Appreciate your time. I know you're all in webinar overload, like I mentioned. If you have any questions, please feel free to reach out to me, and we will take care of it from there for you. Again, be safe, be well, make it a great day, and thanks again. Take care.